Hey you guys, today we're going to be doing lesson 1.1. It's called change in tandem. To start off, a function is a mathematical relation that maps a set of input values to a set of output values such that each input value is mapped to exactly one output value. In previous courses, you may have used the vertical line test to determine if a graph is a function or not. However, in AP Precalculus, we will use the statement each input has exactly one output when explaining why a given relation is a function. We must connect the inputs and outputs. Later in this course, we will learn why the vertical line test is not a valid explanation for a function. In Unit 3, we will discover polar functions. Polar graphs often fail the vertical line test, but they are actually functions. So polar graphs look kind of cool. So they could look like a rose like this, or they can look like a spiral like that. But if you do the vertical line test, you'll see that it fails the vertical line test many times, but those are still considered functions. So when you're given a free response question that's asking you to justify whether a function is a function, if a graph is a function or not, you need to say, yes, it is a function because each input has exactly one output. If you write, yes, it's a function because it passes the vertical line test, that will be counted wrong on the AP exam. All right, moving on. The set of input values of a function is called the domain, which is represented by the independent variable. The set of output values of a function is called the range, represented by the dependent variable. The input values, you might also know them as your x values, and the outputs are your y values. Okay? Moving on, we have two vocabulary words. A function f is positive if the graph of f lies above the x-axis, meaning that your output values or your y values are greater than 0. You can also say that a function is negative if the graph of f lies below the x-axis, meaning that the outputs or the y values are less than 0. So I'm going to zoom in here and draw a little graph. And this horizontal line is my x-axis. On the x-axis, my y values are equal to 0. Okay, this is the x-axis. As you go up on the y-axis, you are going towards positive infinity. That means that as you go up, your y values are greater than 0 because they're positive numbers. If you go down on the y-axis, you go towards negative infinity, towards the negative numbers. So underneath the x-axis, your y values are less than 0. That means that if you're above the x-axis, your function will be positive. If you are below the x-axis, your function will be negative. Okay? Multiple representations. Throughout this course, we will learn and study concepts utilizing the four mathematical representations: graphical, analytical, also known as equations, numerical, also known as tables, and verbal. To be successful in AP Precalculus, we need to be able to identify important information from each representation and construct equivalent representations of functions. So basically what that means is if I give you a graph, you should be able to tell me what the equation is, what the table could look like, and a verbal description. You should be able to also go back and forth. So if I give you a verbal description, you should be able to tell me what the equation is, what the table looks like, what the graph would look like. This may sound scary and or confusing at first, but we will have lots of opportunities to practice throughout the course. Eventually, these ideas will become part of our natural thought process when thinking about mathematical concepts. Okay, let's try our first example. The figure shows an empty vase. At time t equals 0, water begins pouring into the vase at a constant rate until it is full. Which of the following could depict this situation where time in seconds is the independent variable and the height of the water in the vase in inches is the dependent variable? Okay. Now, A common misconception is that because it says at a constant rate, that you look for the graph that's constant. So most kids are going to say, oh, constant rate, the answer would be A because it's a constant line. However, that's not what the question is asking, because it's not asking at what rate is the water getting poured out of the faucet. It's asking at what rate is the vase getting filled at. So notice that our vase has a curvature. It's more wide in the middle and more narrow at the top. Therefore, that shape of the vase is actually going to allow us to eliminate answer choice A. If you think as a vase or a cup that just goes straight down like this, that would be more likely to be the graph of A. Notice that that vase that I drew has no curves, no shape. It's just a straight cylinder. So the water would be filling up at the exact same speed throughout. If you look at C, notice that the height here is decreasing. You see how that's going down? That means that water was getting spilled out or thrown out. So I'm going to write that here. So the decrease in height indicates water being thrown out. However, nowhere in the question did it say, hey, when you're halfway done filling up the vase, I want you to throw some water out and then keep filling it up. So because that wasn't in the question, answer choice C will also be eliminated. So now we're between B and D. So let's explore the shape of the vase a little bit further. So you can see that the base starts off kind of narrow and then it gets bigger. So at this point, we can say that the diameter is increasing. And then as you keep going, you'll see that the diameter is decreasing. So as you get somewhere over here, the shape of the vase gets more narrow. Okay, so both of these, the height of the water is still going to be increasing because we haven't turned the faucet off, because it says that we're filling it up at a constant rate. We're not stopping the water. Okay, so the height is going to keep increasing, but it's going to be increasing at different rates because of the diameter. So when the diameter is increasing, we can say that the height is increasing, but it's going to be increasing at a decreasing rate. The reason it's at a decreasing rate, like I said earlier, at this widest part of the vase, it's just going to take a lot longer for the water to fill up that area. Now, for the top part, even though the diameter is decreasing, the height is still increasing, right? You're still filling the vase up with water. But because the shape is more narrow at the top, it's going to be at an increasing rate. It's going to fill up a lot faster. Okay? So whenever you're looking at these two graphs that we have left, B and D, you want to find the one that has a steeper line at the top. So at the very top, it's going to fill up a lot faster. So if I look at B, notice that at the very top is kind of mellowed out a little bit versus this one is going straight up. Because that one is going straight up, that lets me know that D is going to be the correct answer. So I'm going to just make a little note here that at the top is going to fill up faster. So graphically, that's going to be a steeper line. So all of your graphs should be going up in direction because, again, the height of the water is increasing. But at the very top, it's going to fill up faster, meaning that your rate of change is bigger. So that should indicate a steeper line. Now, later on in this lesson, we're going to learn about concavity, when something is concave up or concave down. When something is changing at an increasing rate, that means that it's concave up. And what that looks like graphically is a smiley face like this. When the height is increasing at a decreasing rate, that means it is concave down, and it's going to look like a frowny face. Okay, so if we look at B, so we just said that we should be starting off with something that looks like a frowny face. But if you look at B, this first half here, if I continue it, that looks like a smiley face. And then it changes to a frowny face over here, if I were to finish it, which is not the correct order that we're looking for. But if you look at D, we have what appears to be a frown at the beginning, right here. And then after that, it changes to something that resembles a smiley face. So that's what we were looking for. At the bottom, it's going to take longer. So you're still going up, but it's going up at a very slow rate. Versus when you get to the top and it fills up faster, you're going to be filling up at a much bigger rate. It's going to indicate a steeper line. So in conclusion, D would be the correct answer and not B. Okay. If you're interested to know, B would indicate more of a narrow middle. So if I erase this, you can see that the steepest part of B is right in the middle. So this part almost goes straight up versus everything else is kind of more horizontal, meaning that it's less steep. So a shape for B would be something maybe like an hourglass, like this. I'm not a very good artist, but it would indicate that the narrowest part is in the middle. Okay, versus ours, which the narrowest part is at the top. So that's why on our graph, again, the steepest part is at the top, like I said here. So even though these are going up still, you see that these lines are not as steep at the very top. Okay. Moving on to some vocabulary words, we have graphical behavior of functions. Increasing and decreasing, you might have heard in your algebra classes in previous years. If your function is increasing, you'll say as the input values increase, the output values always increase. For decreasing, as the input values increase, the output values always decrease. So just as a reminder, you're always going to read your graphs from left to right. Okay, and then so if we're looking at this increasing graph, as you go from left to right, notice that the graph is going up. So that's going to have a positive rate of change, so the graph is increasing. Versus the decreasing graph, as you go from left to right, the function is going down, so it is decreasing. Okay, now both increasing and decreasing are talking about slope. So both of these refer to your slope. Does the graph go up or down? Another way that they can phrase slope is that they can say the rate of change is positive. So if they say rate of change is positive, or they can say F is increasing, both of those would refer to the graph going up. Okay, similarly, if they say the rate of change is negative, or they say F is decreasing, that means that the graph is going down. Okay, so concavity, you probably haven't ever heard of this before. If your graph is concave up, that means that the rate of change is increasing. Graphically, that's going to look like a smile, like I told you earlier. So you see the smiley face here. If you were to add some eyes to it, you could see the smile a little bit better. For concave down, the rate of change is decreasing, and that's going to look like a frown. So if I add eyes there, you can see the sad face. Another way they can phrase this is also them saying at an increasing rate. Or they can say at a decreasing rate. So in this course, there's going to be a lot of different ways they can say something. Okay. Now notice that on concave up and concave down, there's different sections because half of this, as you read from left to right, notice that this half is decreasing, and then after that, it's going to change to increasing. Same thing with concave down. It starts with a positive rate of change, and then it switches to a negative rate of change. Okay? Notice that it changes at a maximum and a minimum. So for concave up, it's going to change directions at the minimum, and for concave down, it's going to change directions at the maximum. Okay, let's keep going. Before we move ahead, it is important that we clarify a few things about the notation and vocabulary that we will use throughout the course. First, when describing features on a graph, we generally write the intervals where the graph displays those features. We will always use the input variable, which is x, when writing your intervals. I'm going to ask that you underline that part. So you're only going to be using x values. I'm going to make a note because sometimes when you read things that are typed, they don't stand out to you. So you're going to do x values only. And then additionally, you're only going to use parentheses. Now, in previous courses, when you write intervals, you were probably taught an open circle would be parentheses and a closed circle would be brackets, which is true. But when you're writing intervals in this class, you can just use parentheses every single time and it will be fine. Okay? If you have more than one, you're going to use the union symbol. So, for example, let's say parentheses. Let's say we have the first x value, x sub 1, and that goes all the way to x sub 2. Let's say there's another interval you need to include as your answer. You're going to put u for union, and then you can include your third and your fourth x intervals. So for example, if I say, what is the interval where the graph is concave down and increasing? Okay, so it's concave down only here where you have the frowny face, but then within concave down, only half of it is increasing. So I can say, okay, well, I think it's from -4 to 0, right? -4 to 0, and then you just put that in parentheses and separate it with a comma. Notice that I only use the x values. I'm not looking at the y values at all, okay? So let's do a practice problem. On example 2, it says the figure shows the graph of the piecewise function f over the interval 0 to 9. What are all of the intervals where the graph of f is increasing? So when it says f is increasing, that is referring to your slope. Okay? Increasing means that the slope is going up. So what I want to do is look at my graph, and I'm going to draw arrows to indicate how the rate of change is moving. Remember, always left to right. So from left to right, I'm going to start off with a positive rate of change. Then I see that it goes down, and then my rate of change is positive again. So I only want to include the intervals where my graph is increasing. So if you look here, I'm only going to include this green area where we were increasing. So those numbers, if you see here in x values only, remember, so we're doing 0 to 3 and 7 to 9. Now, something new in AP Precalculus is that you're going to have a lot of free response questions that you need to know how to phrase so that you get all of your points on the AP exam. The best way to do it is just to rewrite the question in your sentence. So if the question says, what are all of the intervals where the graph of f is increasing? If I restate that, I can say the graph of f is increasing on the intervals Okay, so notice that I've just rewritten the question. I haven't added anything yet. And then after that, I'm going to add the actual answer. So parentheses only, remember? And then the first x value was 0. The next x value was 3. Close the parentheses. Since we had two sections, I'm going to add a union, open parentheses again, and then it was 7 to 9. And then I'm going to finish my sentence. Okay, so just as a recap, only these two line segments were increasing, meaning that the slope was going up. And I only want to include the x coordinates that are coming from the x-axis. Okay, all right, let's keep going. The second thing that needs to be clarified is the phrase rate of change. This phrase will be utilized repeatedly throughout this course and in AP Calculus, so it is important that we understand its meaning. Essentially, the rate of change simply means slope. Anytime we see the phrase rate of change in this course, we can generally replace it with the word slope to help us better comprehend what is being said. We must read very carefully in this course. Stating that f is increasing is very different than stating that the rate of change of f is increasing. Okay? Excuse me. So if it says f is increasing, that's going to be referencing your slope. That means that the slope is going up. But if it says the rate of change of f is increasing, that's talking about concave up. And it's going to be a smiley face. Okay? So the reason that there's a difference there, so if you look at this one, you see how it looks like a smiley face. So this whole thing is concave up. Okay? As you're going through your concave up, this whole thing is decreasing. Then you have 0. Okay, so we have a negative. Let me actually write this down. So at the beginning, you have a negative rate of change until about there. And then it's just kind of at a standstill. I guess it goes down a little bit more. And then it's kind of just at a standstill here. And then after that, even though this one particularly doesn't pick up, I just want to show you what it would look like. Okay, so what that means is that your slopes are increasing. So they're not always increasing, but if, for example, we can say that this slope, and remember from algebra, slope is generally represented by the letter m. Let's say this slope is like -5. Let's say this slope is -4. Let's say this one is -2. Let's say this slope is -1. Okay, so these are still all negative numbers, but notice that those numbers are getting bigger. So if you think about a number line, the bigger negative numbers are all the way to the left. Then you have 0, and then you have all the positive numbers. So if you're going towards the positive numbers, that means that your slopes, all of your slopes are getting bigger, okay? So after that, when you get here, your slope is 0 when you hit that minimum. And after that, your slopes are going to get positive, but they're going to get bigger. So let's say you start at 1, then let's say you go to 3, then let's say you go to 7, and then maybe 11, okay? So when we say the rate of change is increasing and it's concave up, that doesn't mean that the slopes are always positive. It just means that as you go through the curve, your numbers are getting bigger. So these are going bigger if you think about it on a number line. Okay, so it would be -5, -4, etc., 0, 1, 2, and then all the positive numbers. So that's what that's trying to say, is that as you go through the concave up, as you go through the smiley face, all of your slopes that form that smiley face are getting bigger and bigger and bigger. Now, this is referring to the whole curve. When it says the slope part, that means that, okay, well, only half of my smiley face is going up. So those are two different things. Please do not confuse them. All right, so let me erase all of this, and then we can go over some of these bullet points. So the first statement says that f is positive because the outputs, which are the y values, are all positive, meaning that the graph is above the x-axis. Okay, so you can see, let's say this is let's say this is 1, 2, 3, 4, and 5, right? So you can see that all of those y values are positive numbers. So when it says f is positive, that just means that it lies above the x-axis, okay? Now f is decreasing because the output values, which are the y values, decrease as the input values increase. So you can see the graph is going down as you go from left to right. So here's something else to know. F is decreasing if the graph of f goes down. Now remember earlier we also said that the slope can also be read as the rate of change is negative. So I can also say the rate of change is negative, or I can say f is decreasing, and both of those would just refer to the graph of f going down. Now the last thing is that the rate of change of f is increasing because the graph of f is concave up. Okay, so if you were to finish this curve, you would see the smiley face. So the rate of change is increasing. Now what you want to make sure that you're doing is that these two words kind of match up, right? Increasing should mean up and decreasing should mean down. Okay, so what I don't want you to say is the rate of change is increasing because the graph is concave down. That would be wrong. Notice that these two words are contradictory. Okay, let's try another example. So here we have the graph of G. Notice that G is negative because the output values are all negative, meaning that the graph of G lies below the x-axis. So you can see, let's say this is -1, -2, etc. All of those y values are negative. And if you remember from algebra 2, there's these things called horizontal asymptotes, which are these imaginary lines. So in case you're thinking, well, what if the graph is going to go up like that? It's not. It's going to stay forever at this horizontal asymptote, and it's never going to cross over the x-axis there. Okay? Now, on this graph, G also happens to be increasing because the graph of G goes up as you move to the right. So the output values increase as the input values also increase. So you can see that change here. From left to right, the graph goes up. That's referring to the slope. Remember, this could also be said, or the rate of change is positive. Okay? Finally, we have the rate of change is decreasing because the graph of G is concave down. So again, you can see that frowny face. And then notice that these two words match up, right? It'll be decreasing concave down or increasing concave up. Okay, something that's confusing for some students is that how can this say f is decreasing but then we say f is increasing? The reason is that this one doesn't just say f is increasing, it says the rate of change of f is increasing. So you can have both, because remember that on a smiley face and a frowny face, half of it goes down, half of it goes up. Same thing with this one, half of it goes up, half of it goes down. So the entire thing would be concave up or concave down, but only half of it is going to have a slope that is positive or negative. So only half of it is decreasing, half of it is increasing for both. So you can have things that sound like they don't make sense, but they actually do, because you're cutting that smiley face or frowny face in half to where you only see the part that has a positive slope or a negative slope. Okay, let's keep going. Here we have an example. The graph of h of t and its dashed midline for 2 full cycles is shown. 5 points F, G, J, K, and P are labeled on the graph. No scale is indicated and no axes are presented. The t-coordinate of F is t sub 1 and the t-coordinate of G is t sub 2. On the interval t sub 1 to t sub 2, which of the following is true about H? Okay, so there's a lot going on. The most important sentence here is going to be this last one. That's going to tell you what to look at because they gave you a lot of points. So here they want you to focus only from F to G. Okay? Now, if we look at these answer choices, there's two statements here. And it gets confusing when they combine two words together with an and. So what I want you to do is separate those two statements so that they're separate statements. So you see how this H is at the front? I want you to just repeat that H is on the back. So when you read it, you say H is positive and H is increasing. Because sometimes you're going to have extra words at the front that are going to change the meaning of another word, and then it's going to be difficult to keep track of what you're actually doing. So what I'm going to do is add H is to all of these second words so I can read them properly. Okay, so now I'm going to dissect these answer choices. I can see that the first part of this is simply asking me if H is positive or negative. So remember that f of x is the same thing as y, right? Now f of x is any random letter. Usually it's f, but they could also say g, or they can also say h of x. In here, it's actually h of t because that's what they told us, the graph of h of t. So h of t is the same thing as f of x, which is the same thing as y. So if it helps you to read this as y is positive or y is negative, that might help you because you're trying to figure out if your y values are positive or negative. So they're basically asking you, is y positive or negative? All that means is that are you above or below the x-axis? So in order to figure that out, you're going to go to the graph. Now this is a periodic graph, meaning that it's not going to go past these lines here. So you're not going to see this graph go all the way here or this graph go all the way down. No, it's going to just stay forever in this same kind of rhythm. So that means that the highest y value, I can get them from these coordinate points and they should be at the same location. So I'm going to put the y coordinate off to the side. So at the very top, the biggest y value is 4. In the middle, I can see the y value is 0 and the lowest y value would be -4. Now, since they are only interested in the points f to g, I can look at only this top part. Now notice that in here, there are no negative y values. Okay, you have 0, 1, 2, 3, and 4. That means that your y value cannot be negative. So I'm going to eliminate C and D. Okay, so between those two, I need to figure out if H is increasing or decreasing. Now this second portion of the question, when it says H is increasing or decreasing, that's referring to your slope. You need to figure out if your graph is going up or down. So then I'm going to go and look at my graph from F to G. To get from F to G, I need to go down. That means that my slope is going to be decreasing. So that means that B would be the correct answer there. Okay. Question 2 says, describe how the rate of change of H is changing on the interval t sub 1 to t sub 2. Now, some kids' biggest mistake is that they see rate of change and they think slope, and so then they say, oh, the slope is positive or negative. However, they just asked you for the slope here. That means that this question will not be about slope. Okay, so this question will always be about concavity. Okay, do not say anything about the slope here. Now remember, for the free response questions, all you're going to do is repeat the statement back to them. So we're going to say the rate of change of H is. Okay, so notice I've taken this and I've just repeated it. Now, when I get to this word changing, that's where I'm going to insert the change. Is it increasing or is it decreasing? So I'm going to look at here and let's look at the graph. So as we go up, these are positive rates of change, and then it starts to decrease and they become negative. That means that overall, the rates of change are decreasing. And you can see that the graph of H is concave down. So that's what I'm going to put. The rate of change is decreasing because the graph of H is concave down. Now, to get full credit for this problem on your AP test, you have to say both parts. You can't just say the rate of change is decreasing, period. That's going to be marked wrong. You can't say the graph of H is concave down, period. That's going to be marked wrong. They need to see that you're saying the rate of change is decreasing because the graph is concave down. Okay, let's try that one more time. It's a similar problem, but now we have different coordinates. So remember, you're going to want to pay attention to the last sentence. On this one, they want you to look from K to P. So I'm going to highlight that segment on my graph. Remember, you also want to annotate whatever your Y values are on the side. So I see that my highest Y value is -1, the middle is at -4, and the lowest Y value is at -7. So remember that for letter I, number 1, it says, is H positive or negative? All of these Y values are negative, so that means I can already eliminate A and B, because this statement would be false. H is not positive, H is negative. So now we're between increasing or decreasing. Well, to get from K to P, you have to go up. So that means that the slope is positive, okay? So I can put on here Y values are negative and the slope is positive. Okay, so that would be a justification as to why C is the correct answer. Now remember, for number 2, all they want you to say is whether it's concave up or down. To start off, just rewrite the question. We're going to say the rate of change of H is, and now we got to figure out what to change the word changing to. Do I want to put increasing or decreasing? Let's look. So K to P is part of the frown, okay? So notice that we start with a positive rate of change, but then it ends up being negative. So overall, as a whole frowny face, we can say the rate of change is decreasing because the graph of H is concave down. Okay, let's go to the next page. The figure shows the graph of the function k for the interval 0 to 9, as well as the 6 labeled points a, b, c, d, e, and f. Use the graph of k for the following examples. Example 5 says, on which of the following intervals is k negative and decreasing? Okay, so we have 2 words here separated by an and. Remember, I want you to take whatever the question is asking you and put it on the second word. So k is negative and k is decreasing. K is negative means that you are below the x-axis, right? That means that your y values are negative. Now, when it says that k is decreasing, that's referring to your slope. That means that your slope, your line, your graph is facing down. So what I want to do is first start off by writing arrows indicating my slope. So as I move from A to B, I can see that my slope is positive. The same for B and C, my slope is positive. After that, from C to D, I'm going down. From D to E, I'm going down. And from E to F, I go back up. Okay, so this question wants to know, when is the slope going down? Well, that's only happening from C to E, right? However, it also says, when is it below the x-axis? Meaning that all of this above the x-axis is not going to be part of the answer. And neither are the segments that were going up. Okay, so all that leaves me with is the interval D to E, meaning that the correct answer has to be C as in cat. Okay. On these type of questions where they ask you is it below or above the x-axis, I know you guys don't have this thing where you can just shade out. You can just use your hand. So use your hand, the palm of your hand, to cover either the top or the bottom of the graph, so you only see either above or below the x-axis, so you're not confused with extra stuff that you don't have to look at to answer the question. For example 6, it says, which of the following statements about the rate of change of k is true? So all of these answer choices say the rate of change is positive or negative. That is referring to your slope. Okay, does that go up or down? Okay, if you kind of get confused, think about it as slope, right? If your slope, which is usually the letter M, if your slope is a positive number, that means it's going to be going up. If your slope is a negative number, that means it's going to be going down. So that's what we're trying to figure out, okay? So let's go through all of the options. It says from A to B, the rate of change is negative. So that should mean that we're going down. But if you look at A to B, we're going up. So A cannot be the answer. If it had said instead the rate of change is positive, that would be an answer choice, okay? Moving on from B to C, it says the rate of change is negative from B to C. But we said that from B to C, we're going up. So B can also not be an answer. From D to E, it says the rate of change is positive. But if you look at our D to E, we said that it was going down, which would indicate a negative rate of change and not a positive rate of change. So it can't be C either. Okay. Lastly, we have E to F. We said it was going up, and they also said the rate of change is positive, which means that it's going up. So D would be the correct answer there. Okay, for example 7, which of the following statements about the rate of change of K is true? Now notice that these look similar to these. The rate of change of K is, the rate of change of K is. The only thing that's different is that this was negative or positive and this is increasing or decreasing. That change in word indicates that we're no longer talking about slope. Now we're actually talking about concavity. So here you're going to be looking for either a smile or a frown. Okay, so I'm going to move this to the side for a second. I don't know if I'm going to need it later. Just pretend that's not there. Okay, for now I want to annotate the parts where I'm going to have a smiley face. Actually, I'll just leave it. Where I'm going to have a smiley face or a frowny face. Okay, so notice that from A to B, it kind of looks like it could be a happy face, a smiley face. But all of this at the top, all the way almost till D, is a frowny face. But then after that, it changes, and now D to F is a smiley face. Okay, so we have two smiley faces and then one big frowny face in the middle. So we're trying to figure out, I remember concave up is increasing and concave down is decreasing. So let's look. It says from A to B, the rate of change is decreasing. So that means A to B should be concave down. But from A to B, we have concave up. We see a smiley face. That means that A cannot be the correct answer. Next, it says the interval from B to C would be rate of change is increasing. Increasing would mean smiley face. So let's see if that's true. Well, B to C is part of our frowny face. So that's incorrect as well. So B is eliminated. Next answer choice says D to E would be rate of change is increasing. So that should be a smiley face. But from D to E, oh wait, yeah, that actually works because D to E is part of the smiley face and it says the rate of change is increasing. So C seems to be the correct answer. Let's look at D either way. It says E to F, the rate of change is decreasing. That would be a concave down smiley face. But E to F is still part of that smiley face at the end. So Yeah, D is not the correct choice there. Okay. Here we have example 8. On which of the following intervals is K increasing and the graph of K concave down? So K is increasing means that your slope is going up. And when it says that the graph of K is concave down, you should be looking for a frown. Okay, so let's look at the graph for example 8. So again, I'm looking for, now remember a frown has two parts, right? Here's the frown. Half of it goes up, half of it goes down. So I'm looking for the half of the frown where the slope is positive. Okay, so let's see. We only have one frown, which is from B to D. So we can ignore all of this other stuff. Okay, now look at this frowny face. Only half of it was going up. Notice that this other half was going down. That means that this half that's going down would also not be part of the answer. So that means that we're restricted to the interval, it's hard to tell, but B to C. So between B to C, I'm going up, but I'm still part of the frowny face. So I'm concave down, but I'm going up. Okay? So again, the correct answer would be B as in boy. All right, this is the last page. The figure shows the graph of the function f on the interval -5 to 5. On what intervals is f decreasing? So let's start by putting arrows on our graph. From left to right, I go up at the beginning, and then I go down, and then I go up again. Okay? So remember that when it says f is decreasing, that's referring to your slope. And that means that your slope should be going down. When you write your answers, remember that you're just repeating the question. So on what intervals is f decreasing? We're going to say f is decreasing on the interval. So remember, it's x values only. I'll write it again. X values only and parentheses only when you're writing your intervals. So I'm only going down from this point to that point. Okay, notice that that's going from -1 to +2. So parentheses only, -1 to +2 would be my interval that the graph is decreasing. Moving on, example 10. On which intervals is f both negative? So f is negative, and remember to separate. Now we're going to say and f is increasing. So those are two different statements. When it says f is negative, that means that you're below the x-axis. That means your y values are negative. And f is increasing is referring to your slope, and it should be going up. Okay? So what I'm going to do is, since I have to be below the x-axis, now on your paper you can use your hand, but I'm going to cover everything that is above the x-axis. You do not want to be influenced or confused by anything else. You should only be looking at what you need to look at, which is below the x-axis. Now, luckily for us, there's only one line segment, which happens to be going up, which happens to satisfy the second condition that we have. So this interval, so remember it's only up to here, is from -5 to -3. So to write my answer, I'm going to say f is both negative and increasing on the interval parentheses -5 to -3. Now, a mistake that some kids make is that they want to make the whole line segment, and they would say -5 to -1. However, notice that this part that's above the x-axis should not be included. So it is possible to cut a line segment in half if necessary, okay? All right, Last problem, the figure shows the graph of the function g on the interval -5 to 5. Point A is located at -1, 0 and is the only point where the graph of g changes concavity. So I can see that I have a frowny face at the beginning and then I have a smiley face at the end. Okay? Example 11 says, on what intervals is g decreasing and the graph of g concave up? Okay, so when it says g is decreasing, that's asking you for slope, meaning that it should go down. And when you see g is concave up, that means you're looking for the smile. Okay, so I have the smile here from point A all the way over here. So that means I'm going to ignore this frowny face and I'm only going to focus on this. On this frowny face, I'm going, this smiley face, I'm going down till about right there. Oops. And then I change directions and now I am going up. So within the smile, I have half of it's going down, half of it is going up. But I only am interested in the part that's going down. So that could be from point A to about x equals 1. Okay, so for the answer, we're going to say g is decreasing and the graph of g is concave up on the interval, and then again that was -1 to +1. So it's only from here to there that this graph is going down while at the same time being part of the smiley face. Okay, last question, on what intervals is the rate of change of g positive and decreasing? So remember earlier when I said if you have two separate statements and they're separated only by the word and, I want you to look ahead. You see all of this rate of change of g, that also needs to be attached to the word decreasing. So I'm going to add it so that I don't get confused. Okay, so we have the rate of change of g is positive. You can't really see that highlighter. The rate of change of g is positive, and at the same time, the rate of change is decreasing. Okay? When it says the rate of change of g is positive, that is talking about slope. That means it's going to go up because it's positive. When it says that the rate of change is decreasing, that's referring to concavity, meaning it's concave down and you should see a frowny face. Okay? So let's start writing our answer. The rate of change of g is positive and decreasing on the interval. All right, and now let's go look. We're looking for only the part that's a frowny face, right? The concave down part. So we have the concave down part here. So what I'm going to do is add my arrows indicating slope. So when I start off, half of this is going up. We have a positive rate of change, right? These are positive. And then after that, it switches and it goes down. So these are negative rates of change. So we're looking for the half of the frowny face, which is here, but only the half that's going up. So notice that that's only here at the beginning. X values only, that would be -5 to -3. -5 to -3 in parentheses. Okay, and that is the entire lesson. I do want to review quickly just a little chart to hopefully help you understand the vocabulary better because they're kind of repetitive. Okay, so if it says f is positive or f is negative, all that's asking you is the graph above or below the x-axis? If you're given a graph, all you need to see is, are my y values positive or negative? Okay. Now, it gets confusing because know that the positive and negatives can also be attached to this statement, the rate of change is positive or the rate of change is negative. But these two do not mean the same exact thing. This one is above or below the x-axis. This one can also be read as the graph of f is increasing or decreasing, and this is talking about your slope. Does the graph go up or does the graph go down? Okay, so two different ways to ask you about slope. Literally, does it go up or down? They can say, is the rate of change positive or is the graph of f increasing or decreasing? Okay, so again, these two words show up here, but with the extra rate of change at the front, which changes the meaning of just simply positive or negative. Increasing or decreasing also shows up here, again with the addition of the rate of change at the front, which changes the meaning completely. So if it says the rate of change is increasing or decreasing, that's referring to concave up or down, and then you're looking for the smiley face or the frowny face. So here are some examples. The graph of f here would be positive because the entire thing is above the x-axis. Okay, so here's the x-axis and nothing falls below that, so it's all on the top. Now the graph of f, notice that it's going down. That means that the graph of f is decreasing because the slope is negative. That's the same thing on the other one. It says the rate of change of f is negative. So remember that these two are two different ways of asking you the same thing about slope. Okay, so decreasing or the rate of change is negative. Now, lastly, we have the rate of change of f would be increasing because it is a smiley face, it's concave up. The graph of g is negative because it is below the x-axis. The graph of g would be increasing because you can see it's going up from left to right. And likewise, the rate of change would be positive because it goes up. The slope is positive. The rate of change would be decreasing because it makes that frowny face, so it's concave down. The graph of h is positive because it is above the x-axis. The graph of h is decreasing because you can see that the y values are going down. The same thing on the other side, the rate of change is negative because the slope is going down. Last one, the rate of change is decreasing because it's part of a frowny face. Okay, I hope this lesson makes sense. If you have any questions, please let me know. Thank you. Bye-bye.